so close to each other. It's very close, not exactly, very close to the slope of the tangent line. This will be the average velocity, if you want, and this will be the instantaneous velocity. So when I drive and you call me, you're really asking me for the instantaneous velocity. But if I start in Baltimore and I go to New York, you will ask me for an average velocity. But when you call me and say, look at your odometer and tell me what it says, I'm giving you the slope of this line, the instantaneous velocity. So this is what is this. This represents close to, not exactly, but close to the slope of the tangent line. Any questions on this? Any questions on this? Anyone? So let's try and see how that upload works and see if it works for you. Just upload. For now, I'm just letting you upload whatever you want. Whatever you wrote, so I can see it's written correctly and you wrote it correctly, and just upload whatever you want. So see how this works and how long it takes. And the upload is for August the 29th today. And let me know how this works. If it's okay, if it takes too much effort, just one picture. You don't need to upload anything else, just one, so I can see how you're writing. And now, would you like to choose another function, like a radical or a rational function, to determine the difference quotient, which is basically the instantaneous rate of change, almost the instantaneous rate of change, not exactly. Would you like to choose another function? Do you want me to choose a rational or a radical? Please talk to me, say something. My grandma used to say that if you want to crush somebody's spirit, just ignore him or her. So please don't ignore me.
Radical. Radical.
Thank you. Should I still wait for the upload? Do we need more time for the upload, or you guys are as fast as possible?
I'm still uploading.
Okay, just one page, one picture, one thing so I can take a look at it. So in the meantime, I'm going to choose a radical function. Can anyone tell us how to find the domain of such a function? We want, the question is, find the difference quotient. Have we completed the upload, or we still need time?
I'm sorry, I have a question.
Yes?
About the upload.
Yes.
So we're supposed to take a picture of what you just showed us, right?
Yes.
Okay, I did it.
No, not what I wrote, what you wrote in your notes.
Oh, okay, okay.
What you copied in your notes, I want to see.
Okay.
Because what I wrote is going to be posted after class, and you can always go back to it and redo the problems, which I highly recommend. It's the only way to study and to keep up. So are we okay? Can we work on this? No? Anyone? How do I find the domain of such a function first?
Set it greater than or equal to 0.
Yes, but what?
The function under the radical.
Excellent. Excellent. So remember, please, the square root can be applied to positive numbers or 0. And the answer will be real. But the square root of a negative number is not real. As long as this index is even. Oops, I didn't mean to write odd, of course. Even. If it's 2, we know it's by convention not written. We don't write the square root. But if it's 4, 6, 10, whatever, it's even. The quantity called the radicand has to be positive or 0. If it is negative for an even index, it's not real. We love the odd index. Who cares? No restrictions whatsoever. If the index is 3 or 5, 7, no restrictions. So I move 3 divided by 2, x greater than or equal to 3/2. So the domain for this function, bracket, at 3/2, comma, infinity. Excellent. Okay. What we want to do is, however, is the difference quotient, and then after that I promise to stop. Okay, so I copy my difference quotient, which I know is f of x plus h minus f of x divided by h. I know that this is very clear. So this and this are clear. There is nothing I have to do. But this needs a little bit of effort. So can anyone give us f of x plus h? Anyone?
Is that going to be the root of 2 times x plus h minus 3?
Excellent. Great job. Victoria, do you want to teach this class? I can relax a little bit. Just, okay, next time. Okay, perfect. So then we have the square root. No one stopped me, so I'm assuming that this is understood. So everything is okay, I hope. Okay, so please stop me. Don't get intimidated by a few who are answering, please. Good. So any suggestions about something like this? Is there something from our past pre-calc, algebra or pre-calc that we normally do with such expressions? And here's your hint. What?
Multiply it by its numerator.
Not with a minus, by the conjugate. So rationalize, in this case, the numerator. It has to be by the same quantity. So it has to be the same, but with plus. Plus and plus. The conjugate. So the square root of 2x plus 2h minus 3 plus the square root of 2x minus 3. And the same thing, same, because this is 1. So the square root of 2x plus 2h minus 3 plus the same thing, 2x minus 3. So on this problem, you understood then why I have that first day agreement, which is one of the formulas. And this is the other formula. A minus b times a plus b. a minus b times a plus b, which is a squared minus b squared. That's why I review those from the very beginning with my students. Okay. So my little circle. Can anyone give us the numerator? And of course, the denominator, I have nothing to do. It's h, and I have to copy this. The square root 2x plus 2h minus 3 plus the square root of 2x minus 3. Can anyone give us an idea about the numerator?
So it's gonna be 2x plus 2h minus 3 minus 2x plus 3.
Yes, but allow me to write it first like this for everyone to see. So this squared, great job, minus this squared. But yes, I will have to distribute. I stop for a moment to refresh my memory on something very important. Every time I calculate the difference quotient for any function, I don't care, two things have to happen. If they don't, I start from scratch. Here's number one. All terms in the numerator, all terms without h, must go. And then eventually, and this is the correct sequence, you cannot reverse those. This is the first step, and this is the second step. And eventually, h from the denominator must simplify. Notice that h still exists in the final answer. It will not disappear in the difference quotient. But this has to. Okay, so I will continue with 2x plus, sorry about that, plus 2h minus 3 minus 2x plus 3. I copy the denominator. See, I'm not that lazy. Yes, if they don't, I'm in big trouble. Yes, yes. Do not simplify here. Write it again, please. So this is 2h over h, the square root of 2x plus 2h minus 3 plus the square root of 2x minus 3. So number one, all terms without h in the numerator went away. Yes, they did. And now number two, this has to happen. Yes, it does. Thank you very much. So this is the final answer. What is this? Almost the instantaneous rate of change of that function.